Good morning, everyone. Am I audible?
Yes, sir.
Yes, sir.
Yeah. So I'll get started. So I think we have completed reflection part last class. So today I'll try to complete refraction, and if possible, I'll start current electricity also as per the schedule. Right. Um, right. So tell me one thing, is there any doubt you have from reflection concept?
No, sir.
Reflection is clear, right? Okay. Now we'll discuss about refraction. Are you able to see my screen?
Yes, sir.
Okay. So when we talk about refraction, what comes to our mind? What is refraction of light basically? It is bending of light under what scenario? When light travels from one medium to another, right? Vishnu, what should I stop? What happened? Okay. So bending of light when it travels from one medium to another. Here I'm using the word medium, right? So what does that mean? So what is the basic classification of medium that we know? Medium, the plural is going to be media. So what are the two types of media that we know? One is rarer and the second is denser. So what is a rarer medium?
Where
What
light
is a
travels
rarer
at fast
medium?
speed.
One minute, wait. Is my is my voice breaking anywhere?
Yes, sir.
Yes, sir.
Yeah. Is it better now?
Yes, sir.
Yes, sir.
Okay. Now, when you talk about media, right? Media is basically classified into two types. What is it? One is rarer and the
Denser
second
medium.
denser medium. Okay. So what do you mean by rarer medium? What is the difference between both?
In rarer medium, the
Light
speed
travels faster in rarer medium and it travels slower in denser medium.
So if I have a boundary, if I have one medium as rarer and other as denser, so what is the maximum speed of light that is possible? So maximum speed of light that is possible is 3 into 10 power 8 meter per second, right? So on a comparative basis between the two media, if the speed of light in one medium is more compared to the speed of the light in the other, right? So rarer and denser medium are only comparative studies. So they are not absolute values. So if speed of light is more than the speed of light in first medium is greater than the speed of the light in the second medium on a comparative basis, then the first medium is called as the rarer medium, and the second medium is called as the denser medium. Am I right?
Yes, sir.
Take. Now, for us to understand the concept of refraction, what are the important parameters that we need to know? For us to know the concept of refraction, we need to know the concept of refractive index. So what does refractive index mean? It is the ratio of
Sine of angle of incidence to the sine of angle of refraction.
that's right. So is my slide so small?
Yes, sir.
Is it big?
Yes.
Yeah. So ratio of speed of light in
Medium one in any medium to the other medium.
No. So when I talk about refractive index, there are two types of refractive indices. One is called absolute, and the second is
Relative
called
refractive index.
relative. So what do you mean by absolute refractive index? Whenever the definition is asked, they're asking the absolute value.
Compared to where?
Ratio of speed of light in
medium to vacuum.
medium to vacuum. Is this what you're saying? So
Yes, sir.
refractive index is equal to speed of light in medium divided by the speed of light in vacuum. Am I right? Wrong.
C by V.
It is wrong. So it is ratio of speed of light in vacuum to that in the medium. See, this is one common mistake which everyone makes. I'll tell you how to remember. So I told you in the beginning, the maximum speed of light that is possible is 3 into 10 power 8 meters per second. So where does this speed occur? It occurs in the vacuum or air medium also. Okay. And remember, the value of refractive index is greater than or equal to 1. The value of refractive index is always greater than or equal to 1. Since refractive index is a ratio, I repeat it, since refractive index is a ratio, if the ratio has to be greater than 1, then the numerator has to be always greater than the denominator. So the maximum speed is possible in the vacuum, and the speed in the medium can be anything else, but it will definitely be less than that of the vacuum, or at the max it can be equal to that of vacuum. Are you able to understand this point? So this is a way to remember. So what is going to be the SI unit of refractive index? What is going to be the SI unit of refractive index?
Nothing, sir.
Nothing, sir.
No unit, because it is the ratio of same physical
Same
quantity. Yes, it is the ratio of the same physical quantity. So there is no one. Right. Next is refraction by spherical lenses. So when you look at spherical lens, right? So what is basically a lens? Lens is a refracting medium with two surfaces where at least one of the surfaces is spherical in shape. Are you clear with this? So reflecting medium
Yes.
with two surfaces where at least one of the surfaces is spherical in shape. Okay. So if both the surfaces are spherical in shape like this, like what is the name of this kind of a lens? It's called as
Biconvex. Biconvex.
concave or convex.
Convex.
Biconvex.
So you can call it as bicon. Why are you calling it as biconvex? Bi stands for two, convex stands for bulged surfaces. So this surface and this surface is bulged. That's why we call them as convex surfaces, right? Or in simple terms, you call them as convex lens. So what is the other name for convex lens? Is it converging or diverging?
Conversion.
It is converging, right? What about this kind of a lens?
Concave.
Concave lens.
Biconcave lens.
It's called biconcave
Biconcave.
or
Diverging.
simply concave, but it is a divergent lens, right? Suppose, see, this is only for your knowledge. If I have something like this, can I call this as a lens?
Yes, sir.
So that's what the definition says, where at least one of the surface is spherical in shape. If I can call it as a lens, what lens do I call it as?
Concave.
It's called plano-concave. Why is it plano-concave? Because one side is plane, second side is concave. Are you able to understand? So don't worry, they'll not ask you. Just for your knowledge, I'm saying, so that you can think better. Is this point clear? So just to
Yes, sir.
look at your understanding, can you tell me what will this be called as?
Plano-convex.
Plano convex.
It's called plano-convex. So what happens is, actually you need to place your eye here from outer surface. When you place your eye here and observe from the left, it is appearing like a plane. And when you place your eye here and observe, it is appearing like a convex surface. That is why it is a plano-convex. Okay. Now, the next question is about the ray diagrams for lenses. So when you draw the ray diagram, before that, I need to tell you what are all the parts related to the lenses. Can you tell me?
Optical centers.
1 minute. I'll take some empty slides. Parts of spherical mirror. So if I take a lens to be in this format, okay. Right, if I take the lens to be in this format, tell me what are the parts associated with it? The center of the lens.
Sir, your screen is dark, sir.
Sir,
I
your
can't see your screen.
Your screen is not visible.
No? Is it big or small?
Small.
Small.
Smaller. Now is it better?
No, sir.
No, sir.
The same, sir.
Same.
Now it's okay, sir.
Now it's okay. Huh?
Yes,
Yes,
sir.
Yes, sir.
So parts of a spherical mirror, this is called as the optical center. Then for this surface, if I complete a circle like this, then the center of curvature will be here, which I'll call it as C1. Similarly, the center of curvature for the second surface will be on the left, which I'll call it as C2. Am I right? So what is the distance from the optical center to the center of curvature called as? It is called as the radius of curvature, and the center distance from the center optical center to the second center of curvature is called as the second radius of curvature. What did I use?
You said mirror. The title also says mirror.
Okay. The center, the distance from the optical center to the center of curvature of the lens. Oh, I wrote parts of spherical mirror. Sorry, lens. So parts of spherical lens. right? Now, if I have to define another point called as the focus, so how is it going to be? Suppose I take a ray parallel to the principal axis, right? You know what it is? This is a principal axis. So what is the principal axis? It's an imaginary line that is passing through the optical center and the center of curvature. So when I take a ray parallel to the principal axis, after refraction will pass through a point on the principal axis, which is called as the focus. And this will happen for what lens? This will happen for a convex lens, right? Next is for a concave lens. So if I take a concave lens, this is again going to be the optical center. Here I'll have C2, here I'll have C1. Right? And this distance is going to be R2, this is going to be R1, and all those things are known. So if I take a ray parallel to the principal axis after refraction, so you will have the ray diverged and the image will be formed somewhere over here. It's called as the focus, right? Now, see, tell me the rules to draw ray diagrams for lens. Tell me the rules to draw.
Sir, if it's parallel to the principal axis, it passes through the focus.
Ray considered parallel to the principal axis will pass or appear to pass through the
Focus.
focus. So why did I say pass or appear to pass? Pass will
Concave
happen.
lenses.
Pass will happen for convex and appear to pass will happen for concave. Okay. Second, ray through the focus, what will happen?
It will appear parallel to the principal axis.
After reflection will
So isn't
pass.
it after refraction?
Oh, sorry, ma. After refraction will pass through, will pass
Parallel to the principal axis.
parallel to the principal axis, right? Third, so ray through optical center. So what will happen to the ray through the optical center?
It won't
Because
refract.
it pass through without any deviation.
Will travel without any deviation. Right. Now, I have a question. What are the laws of refraction?
Angular.
Incident ray,
Normal ray.
refracted ray, and normal. Normal is not a ray actually. Normal is just a
All
line.
lie in the same plane.
All lie in the
Plane.
same plane. Second,
The
there is
ratio of sine of angle of incidence to the ratio of to the sine of angle of refraction is equal to a constant.
sine of angle of incidence to the sine of angle of refraction is a constant. And what is that constant called as?
Refractive index.
The constant is called as the refractive index, right? So based on this, if I write sin I by sin R, can I write it as mu? Right? So if I write only mu, it is called as absolute refractive index. Whereas if I have to write something as relative refractive index, then what should I write it as? I'll write mu to 1. So what is mu to 1? It is mu 2 divided by mu 1. Now listen to this carefully. If I take this to be the boundary, if I take this as the first medium and this as the second medium, if mu1 is the refractive index here, mu2 is the refractive index here. mu1 is the refractive index here and mu2 is the refractive index here. There is a ray incident on the boundary. If I take this to be the angle of incidence, then what will happen to the ray? The ray was supposed to travel in this path, which we call it as the actual path. Right? We call it as the actual path. So now, when the ray starts bending, it gets deviated from its actual path. Means it can start either turning in the clockwise direction or in the anti-clockwise direction. If it turns in the clockwise direction, what do you call this as? It is said to be bending towards the normal. And when it is bending in anti-clockwise direction, you say it is bending away from the normal, right? So if I take this to be the angle of refraction, okay? So incident ray, refracted ray, and the normal all lie in the same plane, accepted. Now the next question is, sine of angle of incidence divided by sine of angle of refraction is equal to, I want you to write it in terms of mu2 and mu1. How will you write it? So you told sin I by sin r is equal to mu, no? That is absolute refractive index, where if one of the media is vacuum, then okay, you're safe. Here, how do I write it? Because I have two different media. So how do I write it? I'll write it as mu2 divided by mu1. Okay, which implies mu1 times sin I is equal to mu2 times sin r. If you don't know this, please make a note of it. So what I'm saying is, if you want to apply Snell's law, right, take the refractive index of a medium. So mu1 multiplied with sine of the angle of incidence, okay, refractive index of a medium multiplied by the sine of the angle in that medium is equal to mu2 into sine of the angle in the other medium. Are you able to understand what I'm saying? Mu1 into sine of angle in one medium is equal to mu2 into sine of the angle in the other medium. Is that point clear?
Yes, sir.
Okay. So have this in your mind. Now tell me, having this in mind, when light travels from rarer to denser medium, what happens? When light travels from rarer to denser medium, why is it bending towards the normal? Right? It is bending towards the normal. So what is happening here is, observe. I have another question. I have refractive index of rarer medium and refractive index of denser medium. Which refractive index is greater?
mu2.
Why? Why do we say refractive index of denser medium is greater? How do we know that?
Speed of light is slower in density.
How do you know? What is the relation between speed of light and the denser medium's refractive index? So let's try to prepare a small flow chart so that we'll understand things better. So you're saying mu is equal to C divided by V. So refractive index of a medium is equal to speed of the light in vacuum to the speed of the light in the medium. So from here, can I say refractive index is inversely proportional to V? So if the refractive index of rarer medium is called as VR and the refractive index of the denser medium is called as VD, can I say if I say the speed of the light in rarer medium is VR and the speed of the light in denser medium is VD, can I say VR is greater than VD? Which implies mu R will be less than mu D. Am I right? So are you able to understand these points? See, all these kind of questions might come in assertion reasons. So please be careful with the theory part as well. It's not only about problems. Are you able to understand why the refractive indices are inversely proportional? Yeah, I mean, they're following the reverse pattern. It is because of the speed of the light. But here I have a question. Listen, if this is there, if I take this to be the angle of incidence and I take the refractive index of the rarer medium here to be mu R, and if I take the refractive index of the denser medium as mu D, okay. So refractive index of rarer medium is mu R and the refractive index of denser medium, I take it as mu D, and the light is traveling from rarer to denser medium. So what will happen here is, listen to this carefully. When I apply Snell's law, mu R into sin I is equal to mu D into sin R. Do you guys remember this? I just now told you. The refractive index of a medium into sine of the angle of incidence in sine of the angle in that medium is equal to refractive index of the second medium into sine of the angle in that medium. Right? So if I write sin I by sin R, then what will this be equal to? It will be mu D by mu R. Am I right? Guys, I need some response.
Yes, sir.
Yes, sir.
Yes. So
Yes,
what is the ratio of refractive index of denser medium to the refractive index of rarer medium? Will that value be less than 1 or greater than 1? Look at this, no. Refractive index of denser is greater than the refractive index of rarer. So a bigger quantity divided by a smaller quantity will give you the ratio to be
Less than 1.
greater than 1, no?
Greater than 1.
Yeah, yes.
Numerator is more. So when it is greater than 1, then can I say sin I by sin R is greater than 1? Which implies
Yes.
sin I is greater than sin R. Is that clear? So sin R will go to the other side. Sin I is greater than sin R. Are you able to understand till this step?
Yes, sir.
yes, sir.
Right. My question is, you know the trigonometric table. So where do you prepare the trigonometric table from 0, 30, 45, 60 and 90? Right. When you prepare it for sine, it's 0, half, 1 by root 2,
2, 3 by
root
2, 1.
and 1. So when you go from 0 to 90, means when the angle is increasing, right? What is happening to sine of that angle? Is it increasing or decreasing?
Increasing.
Increasing.
0, 0, half is 0.5. Yeah, it is increasing. 0.707. Root 3 by 2 is 0.86 and 1 is obviously 1. So you're able to see that as the angle is increasing between 0 to 90, sine of the angle will also increase. So when I say sine I is greater than sine R, can I say angle I is greater than angle R?
Yes, sir.
Yes, sir.
Right. So if that is the case, how much will this angle be? For the diagram that I have drawn, it will still be angle I only because they are vertically opposite angles. Now, I am saying when the light is traveling from rarer to denser medium, sin I should be greater than sin R, means I should be greater than R. So where should the refracted ray be? It should be in such a way that the angle of refraction is less than the angle of incidence. That is the reason why it starts bending towards the normal. Is it clear?
Yes, sir.
So it is not like it happened on its own. So Snell's law is giving you the expression. So they might not ask you to prove this. They might say in assertion and reason, they might put a question like this: on what basis are we saying that when light travels from rarer to denser medium, it starts bending towards the normal? Which law can be used to prove it? What will your answer be? It is going to be Snell's law. Okay, that is why this law is very, very important. Are you able to understand this point? Just take a screenshot and have it. You can copy it later. So I'll be back in a minute. So using the same theory, we can prove the reverse also, that I'm not going to do. When light travels from denser to rarer, it starts bending away from the normal. If this point is there, we are going to apply it and we'll find the answers for it. Now, tell me, somebody's mic is on, please switch it off. Now we'll see the ray diagrams for lenses. First ray diagram. I mean, how many ray diagrams are there for convex?
Six, sir.
Yes. They are 6. And for concave,
2.
2. So for convex 6, where all will you place the object?
Infinity, beyond C, at C.
So when the object
No.
is placed at infinity, where is the image formed?
At
Focus.
F2.
Focus.
So at infinity, it is formed at focus. And what is the size of the image?
Point size.
Highly diminished point
It is
size.
size. Okay. It's a highly diminished and point-sized object. Then what about the nature of the image formed? Is it real or what?
Real and inverted.
Real and inverted.
Real and inverted. So with respect to a lens, when will you say it is real and inverted? Means if the object is on one side and the image is on the other side, you say that the image is real and real images are inverted. So next is when you place the object,
Focus.
beyond center, no? Beyond center of curvature. So when you place it beyond C, what will happen? The ray after refraction will pass through the focus. That is one of the
Between focus and center of curvature.
points. So if I take this to be AB, this would be A dash B dash. So when you place it beyond C, where is the image formed? Between
Between F and C.
between C. Then what about the nature? It is real and
Inverted.
inverted. Then what about the magnification?
Diminished.
Diminished.
So when I say diminished, the magnitude of magnification will be less than 1 or greater than 1?
Less than 1.
Less than. Okay. Next is when you place it at C, what will happen?
The images.
When you place it at C, the image is formed at
See.
At C.
C. What is the nature? Real and
Real and inverted.
what about the magnification?
Same size.
Same size. So what will be the magnitude of magnification? It will be 1.
One.
See, I'm not drawing the ray diagram because I assume that you know it. Is there anyone who wants me to draw? So between F and C,
Beyond focus.
Beyond C.
there is nothing like beyond focus. No. Beyond focus is it can be between center of curvature or after. It can be before center of curvature or after that. So what will
Beyond
be the
C.
answer? And real and inverted. What about the magnification?
More than one.
Large.
Large, so magnification will be greater than 1. So when you place it when you place it at F,
At infinity.
the image is formed at infinity. Real and
Inverted.
magnification.
Highly enlarged.
Highly enlarged and magnification value will be infinity, right? Between F and optical center, where is the image formed?
Same side of the object.
Same side of the object. Then what about the nature?
Virtual and
Virtual and erect.
Virtual and erect.
Virtual and erect. Then what about the magnification?
Enlarged.
So magnification will be greater. Is it clear? So this is the only place in a convex. So the advantage with the convex mirror is it forms a virtual image and that virtual image is enlarged because with respect to a concave, let's see what is going to happen. So let's see what will happen with respect to a concave lens. So where do you place for the concave lens? One is at
Infinity.
infinity. Where is the image formed?
At focus.
Focus.
What about the nature?
Virtual and erect.
Virtual and erect. Then what about the magnification?
Highly
Point size.
diminished and point sized.
Highly diminished and point sized. That is magnification will be 0. Right? If I'll just draw the diagram for this. If I take the lens to be in this way, when I take a ray parallel to the principal axis after refraction, it is going to form an image at the focus. Right. So this is how it works. Where will be the second point you will place?
So how can the magnification be 0?
It can be, no?
How can
Because
it-
it's a point-sized object, no? When size is not defined, magnification is 0. That is the meaning of point size.
Okay.
That is why we use the word highly diminished.
Okay, sir.
Next. Where will you place it?
Between optical center and infinity.
Yes. You place it anywhere you want. What will happen to the image? So you place it anywhere you want. What is going to happen?
The image will be formed between the focus and the optical center.
Yes. Because if this is going to be the focus point, if I take a ray through the optical center, right, it will go undeviated. So the image will be formed here. So if this is going to be AB, this is going to be A dash, B dash. Now what about the So at any point between O and infinity, where is the image formed? Between
Between F and
O, the nature is virtual and erect. What about the magnification?
Diminished.
less than 1.
So less than 1. So it is diminished. Right. So major part of the chapter is over. So the only thing that we need to know is the sign convention part and the lens formula magnification, and then we need to start solving the problems, right? So I hope it is clear till this step, no? See, these are all the points you already know. It's just a revision. Is there anyone having any doubt? Is there any point you want me to explain again? Please let me know. Okay. So when I talk about the sign convention with respect to a lens, if this is going to be the optical center, any distance measured on the left of the optical center is negative. Any distance measured on the right of the optical center is positive. Any distance measured upwards is positive, and any distance measured in the downward direction is negative. Is the point clear? Right, it's very simple.
Yes, sir.
Now, what about the lens formula? Lens formula is 1 by V minus 1 by U is equal to 1 by F. So what was mirror formula?
1 by
1 by
V
V
plus 1 by U is equal to 1 by
plus 1 by U is equal to 1 by F. Yeah. The thing is, see, derivation part is not there for you, but just to give you an idea, yesterday we discussed triangles, right? So the concept of this 1 by V minus 1 by U is equal to 1 by F is actually derived using the concept of similarities of triangles. Okay. So your math is also applicable here, like how trigonometry helped you in the case of deciding whether the ray will bend towards or away from the normal. Similarly, triangles will help you to derive this formula. Okay, you need not worry about it, just for your information I'm giving you. Similarly, what about the magnification of a lens?
V by U.
That's it. So magnification of lens is going to be V divided by U. Whereas for magnification of mirror was minus
V by U.
Minus V by U.
Last concept is power of lens. How do you define the power of lens as?
The reciprocal of its focus.
Reciprocal of its focal length. It is represented by the symbol capital P, by the letter capital P. And how is power measured? It is measured in terms of diopter,
Diopter.
right? And the symbol used for diopter is capital D, right? So power is written as 1 by F if F is given in terms of meter. Suppose the focal length is given in terms of centimeter, you write it as 100 divided by F when it is given in terms of centimeter. Am I clear with this?
Yes, sir.
Right. So based on this, shall we start solving problems?
Yes, sir.
Tell me what kind of
Convex lens.
Convex lens.
this one is convex, sir. How did you say?
Convex.
How did you say convex?
Sure, the rays are converging and passing
What is the
through.
hint? What is the hint that you got? 10 is coming out like this. So it's getting converged, correct. So it is going to be convex, correct. So refractive index of water with respect to air is 4 by 3. The refractive index of air with respect to water will be
3 by 4, 0.7.
yes.
0.75.
The refractive index of water with air is 4 by 3. So refractive index of air with water will be 3 by 4, which is 0.75. Right. A student has to do an experiment on finding the focal length of a given convex lens by using distant object method. Did you guys go to the lab and do?
Yes, sir.
So when I say distant object method, what do you generally do? You'll open the window and you'll focus on some.
3.
and you will get an image that will give you the approximate focal length of that particular lens, right?
Sir, is the answer option B?
She can do her experiment if she is also made available with.
Scale and screen.
Share and screen.
One minute. A student doing finding the focal length of a given complex using. Yes, a scale and this. So D, protractor used for measuring the angle of incidence and the angle of refraction has position in the ways illustrated for finding the angle of incidence. So for you to find the angle of incidence and angle of refraction, how should you place them? Angle of reflection, sorry.
Is it X and Z, sir?
Tell me, think and tell me. Is it right? Others? I got one answer. What about others?
It's X and Z.
X and Z?
Sir, X and Z, sir.
Yes. Just give me a minute. So 1 minute, I'll show you another problem. Do this. What is the answer?
Bend towards normal.
Bend towards the normal.
A rate, right? It's a simple question. A bend towards the normal. So I didn't see that. Okay, dispersion, you know, right? Actually, it is not from this chapter, but you know what is dispersion of light, right?
Yes, sir.
So why does it happen?
Difference in wavelength.
Difference in wavelength.
Draw this. So this we have already drawn, no? So when the object is placed at the focus, so how will you draw it? Just give me a minute, wait. I have pain and neck. I'll be back. Yeah. So did you draw it? See, listen. Draw a ray diagram showing the image formation by a concave lens. By a concave lens when the object is placed at the focus, right? So when you place the object at the focus, what is going to happen? At the focus, if you place an extended object, let me call it as AB. So how many rays are needed for you to complete the ray diagram? What are the minimum number of rays required? 2. So how will you consider one of the rays as? You will take the ray parallel to the principal axis. So when you take it parallel to the principal axis, after refraction will pass, will get diverged like this. So when it is getting diverged, it appears to pass like this. Then what is the other ray that we can consider?
It passes through the optical center.
When you take another ray through the optical center, right? So we feel that these two rays are actually intersecting. So where will the image be formed? It will be formed between the optical center and the focus. Make sense?
Yes, sir.
Right. So when they say when an object is placed, right? See, generally when you draw a ray diagram, there are 2 types of objects that we can consider. One is point-sized object, and the second is extended object. So what do you mean by extended object is an object that has a finite size associated with it. Am I clear with that? So this is an extended object, and when an extended object is placed at the focus, this is how the ray diagrams will look like. Shall I proceed?
Yes, sir.
This is simple. Read the question. They didn't ask you to define the power of lens. They asked you to define 1 diopter of lens. 1 diopter of power of lens. How do you define it? If power is equal to 1 by f, right? So when will this be exactly 1 diopter?
When focal
When the focal length is 1 meter.
Right. When focal length of the given lens is 1 meter, power of the lens is said to be 1 diopter. Right. So one more question, simple. Do this. A convex lens has a focal length of 15 centimeter. So one question I forgot to mention this. For convex lens, focal length is positive or negative?
Positive, sir.
And for concave lens, focal length is
Negative.
negative. So here focal length of concave lens is given. So I should take minus. So at what distance should the object be placed from the lens, right? So that it forms an image at a distance of 10 centimeter from the lens. So we expected is 10 centimeter from the lens. But here the trickiest part is,
It's
I
negative,
will
sir.
not, that's what I was about to stress on that. But the trickiest part is we don't know whether we should take it as positive or negative. I should take it as negative because of
Because
what reason?
concave lens, sir. Will
Concave
form an
lens will
image.
always- Yes, will always form image on the same side as that of the object. Okay, now U is there. So U, when you solve it, you will get the answer as negative or positive. When you solve it, U should come out as negative, but since it is an unknown, you should not take the sign convention of it into consideration. Okay, so when I apply the formula 1 by V minus 1 by U is equal to 1 by F, 1 by V is minus 10.
U is equal to minus 30 centimeter.
But did you take U is equal to minus U here?
Yes, sir.
When you applied it here, did you take U as minus U?
Yes, sir.
Don't do that.
Why,
Don't do
sir?
that. Okay, that is what I'm stressing on. So when you're solving a problem based on lens or mirror formula, whatever is an unknown, do not take the sign convention of it. When you solve it, the final answer itself will give you with sign convention. Okay, in this problem, you escape because you know U is negative. But if there was a problem where they twisted, sometimes you can be positive also.
Sir, but all are always placed on the left side, right?
It is placed, but if they want, that's what I told. If they want to twist it, it is slightly of higher order thinking skill. Not necessary. It is my wish, no. It is my wish. See, by
Yes.
default, if nothing is mentioned, right? That is what I'm stressing. Listen to this very carefully. Okay, they might twist it. By default, if nothing is mentioned and they give you object distance, right? By default, it is negative. Okay. But not necessary that the object should always be placed on the left-hand side. There might be problems where they will stress and say that the object is placed on the right-hand side also. If they mention it, then you need to be very, very, very careful.
Sir, if placed on the right side, we need to take object distance as positive, right?
Positive.
Yes.
According to which, but object distance will be positive. But according to which, what will happen? The focal length and all will still be negative. You're able to
Yes,
understand.
sir.
So things will change accordingly. See, 99.9% they will not do that. Okay, for boards, they will not do it. But I'm just trying to be more cautious. That's it. Okay. So the point I want to convey from this problem is whichever is an unknown, please make it, mark it as important. Whichever is an unknown, do not apply sign convention. So this will go to the other side. Minus 1 by u is equal to 1 by 10 minus 1 by 15. So what will be the answer?
Minus
Hold on.
30 centimeters, sir. U is equal to minus 30.
Minus 30 varada plus 30 varada.
Minus 30, sir.
Minus.
Sure.
Yes, sir.
15 minus
So
10
minus
divided by 150. So 30. So you minus it is 30. So you will be minus 30.
Yes, sir.
Okay.
Magnification is 0.33 centimeters, sir.
V by u. V and u both have the same sign. So minus 10 divided by minus 30. Cancel it. 0.33. Is it right?
Yes, sir.
Okay. For example, I'll ask you this question. Listen to this carefully. For example, had they asked the question, what should be the value of u for the image to be formed at v is equal to 20 centimeter? Okay, I want take the same parameters. Okay, take the same parameters and solve and tell. What should be the value of u for v to be 20 centimeter?
Sir, I got 8.57 centimeters.
You got plus, no?
Yes, sir.
But if you ask me, you should have not started solving it. Why? Think about it. What kind of a lens is this?
Concave.
Because in concave lens, the object lies in between focus and the optical center.
Not object. Correct yourself, Tanishka. Not object.
The
It is
image.
Image.
right. So wherever you place, you will not actually get it. You will actually not get it. You're able to understand? So these are all the parts you need to be careful with. So always don't concentrate on the formula, concentrate on the numbers. So focal length is 15. This is 15. You need to place the object so that the image is formed beyond focus. Why I'm using word beyond focus is, I'm not concerned about center of curvature for concave lens. Is there a possibility where image can be formed after the focal length, after the focus point?
No, sir.
No. So this kind of a scenario is not possible at all. Right. So do this.
So, sir, if
We-
such questions come, we directly have to tell that the scenario is not possible.
Not possible. They will not ask you here. They'll ask you an assertion reason. They'll
Okay.
not ask. Okay. So what they will do is they'll give you this kind of a statement and they will ask you whether this kind of a scenario is possible.
Okay, sir.
I mean, like, see, he reported the answer as 8.57, right? They'll give that as the reason. For example, what you should see is, based on that, you should decide. Okay. I'll tell you when that problem comes. I'll tell you.
Okay, sir.
So we wish to obtain, so observe, read the question. We wish to obtain an equal sized inverted image of a candle flame on a screen kept at a distance of 4 meters from the candle flame. Name the type
Sir.
of the lens that I need to use.
Convex lens.
Convex
Equal
lens.
sized and inverted, when will you get it? For a
Placed on 2F, sir.
convex lens. That is the center of curvature. So what should, so type of the lens is convex lens. What should be the focal length of the lens and at what distance from the candle flame from the lens? And at what distance from the candle flame from the lens be placed? Okay, U is equal to how
Sir,
much?
is focal length 2?
Yes, because
2F
2F
is equal to 4. So,
so
F is
F
equal
will
to
be
2.
2 centimeters. So is it plus 2 or minus 2?
Plus 2.
So focal length is plus 2. What is the object distance?
4.
Minus.
They have already given it, no? Minus 4. So, oh, it is in meter, sorry. Minus 4 meter. Draw a label diagram to show the image formation in this case. Means you need to take the convex lens. This is focus. This is 2F. So when you place the object here, one ray parallel to the principal axis after refraction will pass through the other focus. The second through the optical center will go and hit here. And this is going to be 2F. Am I right?
Sir, how did we get F equal to 2 meters?
F is equal to meter, huh? Because we wish to obtain an equal sized image of candle on a flame on a screen. A screen is kept at a distance of 4 meters. So since they told equal sized inverted image, then the object is also kept at the same 4 centimeter on the left of it, because what kind of a scenario is this? A convex lens where the object is placed at the center of curvature. Only then you will get the same image. No?
Yes, sir.
Yes, sir. Got it.
Got it? Huh?
Yes, sir.
Yes. Simple question. The refractive index are 1.003, 1.31, 1.5 respectively of air, ice, and benzene. And which of these does the light travel faster?
Air.
The first one. They ask you the reason, because the refractive index is less. So atmospheric refraction we'll discuss later. Distinguish between convex and concave lens, you already know. Can you draw this? Draw a labeled ray diagram to show the path of a ray incident obliquely. What is meant by obliquely? What is oblique? See, suppose there is a glass slab. Any guess at least?
Sir, like angle of incidence will be equal to angle of reflection of refraction.
Kadayadu. See, if the ray is incident like this, right?
Yes, sir.
This is
Normal.
I will say ray is incident normal to the surface. Okay, that is one language I will use. If I have to speak in terms of incident angle, what is the other point I'll use? I'll say incident angle is
0 degrees.
it is 0 degree. Most common mistake is they write it as 90. So when the angle of incidence is 0 degrees, you say the ray is incident normal to the surface. So if the angle of incidence is anything other than 0 degrees, listen to this, guys. If it is anything other than 0 degrees, it is said to be incident obliquely. If you don't know this, please make a note of this point. Am I clear?
Yes, sir.
So if it is incident obliquely, means the angle of incidence is anything other than 0 degrees. Calculate. So they are asking us to complete the ray diagram. Now I'm going to explain this. Listen. If the angle of incidence is here, is I, okay, and the ray is traveling from air to glass medium, okay, it's called as a glass slab, right? Then what will happen to the ray in the first place? Then what will happen to the ray in the first place? So this is the angle of incidence. The ray is traveling from rarer to denser
It will
medium.
bend towards the normal.
It will bend towards the normal, right? And the refracted ray will start acting as the incident ray for the second refracting surface. So what will happen to it? It will start bending away from the normal. So when you extend the initial incident ray, then how will this incident ray be with respect to the emergent ray? It will be parallel. So if this angle is R1, this angle is R2, then the angle of incidence will be equal to the angle of emergence. Right? So what is the first ray called as? It is called as the incident ray. And what is this ray called as? It is called as the refracted ray. And the third ray is called as the emergent ray. Is it clear? You have seen this diagram, right? You would have drawn it. Did you do this activity in your lab?
Yes, sir.
Good. Okay. No. Let's solve the next two parts also quickly. Calculate the refractive index of the material of the glass slab. So if I take the refractive index of the material to be mu, okay, given that the speed of the light through the glass slab is 2 into 10 power 8 meters per second and in air is 3 into 10 power 8 meters per second. So what is mu equal to C divided by V? So what is C? 3 into 10 power 8 divided by
3
V
by
is 2. 10 power 8. Cancel these. Answer will be
1.5, sir.
1.5.
so refractive index is 1.5, or you can write it as 3 by 2. Okay. Next is calculate the focal length of the lens. So what kind of a lens is this? Focal length is negative. So what kind of a lens will be? It is a
Concave lens.
concave lens. So what is going to be the focal length? Minus 2.5 is equal to 1 by f. So f is an unknown, so I didn't use the sign convention. So f is equal to minus 1 divided by 2.5. So minus 1 divided by 5 by 2. So minus 2 by 5 or minus 0.4 meter. So minus 0.4 meter, or it is also going to be 40 centimeters. Is that clear?
Yes.
And we are done. Right. So remaining problems are there in the assignment sheet. You can go through them and solve it. Did you all receive the assignment sheet?
Yes, sir.
Yeah. So I hope you would have solved these problems by now. Okay. So just give me a minute. Don't leave. Yeah, now you can leave.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.